Hello everyone, I welcome you all for the course Manipulator Robotics. It's a theory course. In the last video, we have discussed DH formulation. How do we get the DH parameters? Okay, so now we are going to apply those DH formulation in the problems. So we are going to take few manipulators, and for all those manipulators, I will tell you how to do the DH matrix. Okay, so that's what we are going to do today. Okay, so DH formulation numericals. So first, let us take RP manipulator. Okay, so RP manipulator. So let me take the base, and this is my, the for this. So it rotates like this. Okay, so this angle is theta 1. Okay, or theta also we can have. And next one is prismatic. So revolute is this one. Prismatic is, it moves like this. Okay, so here we have the end effector gripper. Okay, so now, this is my RP manipulator. So this moves like this. Okay, this distance is dt. Okay, this distance moves like this, and here is the theta 1. Okay, so what is the first step? First, you have to assign the axis. Assign the axis. First axis is z you have to assign. So how do you assign? If it is revolute, then you have to in how to fix the z-axis for the revolute joint. If the joint rotates about an axis, so z-axis is about an axis. If it is prismatic, it is along the axis. So how do you give z-axis? If it is revolute joint, it is about an axis. If it is prismatic joint, it is along the axis. So let's see that. So here, let's take the revolute joint. So what is the rule? Revolute joint means you have to assign z-axis for the rotation about the axis. So here it rotates like this means, so this is the axis of rotation. Okay, so this axis of rotation, let me call it as 1. Then let us take the same thing as reference also, so that it will be simplified. Okay, then here comes my x naught. This is basically it, you should not change. So x naught and z naught 1. Then you have to assign prismatic. So prismatic is along the axis. So where is your movement? The movement is along this way. So this is my z. Okay. So your z1 is about the axis of rotation, and z2 prismatic is along the axis of rotation. Okay. So now, so first point is you have to assign the axis, then you have to assign x-axis. So if the axes are parallel, then you have to draw the common normal for that. Okay. But here, if you want to mark x1, you have to consider z0 and z1. Okay. If z0 and z1 are intersecting, then your x1 is perpendicular to a plane containing z0 and z1. Okay, I'll write here. So when do you write x1, or when do you say what is x1? X1 means it is perpendicular to a plane. That plane contain z0 and z1. Okay, so here x1 means z0 and z1, whereas x2 means z1 and z2. So x1, let's draw x1. So what is x1? Perpendicular to a plane containing z0 and z1 if z0 and z1 are intersecting. So excuse me, z0 and z1 are intersecting. So let's say z0 and z1 are intersecting. So in this case, what you have to do? You have to draw a x1 axis that should be perpendicular. So here, this plane containing this one. So I'm going to take, this is my x1 axis. Okay. So here, this is my x1. Okay, x1, because this x1 should be perpendicular to this, or in some book we can do like this also, but the concept is This is x1. So the concept is it should be perpendicular to a plane containing this. So this is the plane. So now this is the plane. To this plane, this is okay. So let's not take this value. I mean, let's not take this one. Okay. Okay. So now your x1 is, I mean, this is the plane, this plane containing z0 and z1. Your x1 is perpendicular to a plane containing z0 and z1. Okay. So let's do x2. So for x2, you have to consider z1 and z2. So your z1 is here, your z2 is here. So anyway, if you drag this, it will intersect. So if z1 and z2 are intersecting. So if z1 and z2 are intersecting, then you have to assume a normal. Okay, this is a plane. So this is a plane containing z0, sorry, z1 and z2. So to this, x2 should be perpendicular. So this is my x2. Okay, so this is x1 and x2. So we have drawn everything. So now we have to do the DH table. Okay, so let's do the DH table. So your DH table here 0 to 1, 1 to 2, and then the table is A alpha D theta. Okay, so already we have discussed what is A, distance between Z0 and Z1. Okay, so here Z0 and Z1 are same at the same point. So there is no distance, so it is 0. Okay, and then angle is angle between Z0 and Z1. Angle between Z0 and Z1, so that is also intersecting, so that is 0. And the next one is distance between X0 and X1. So X0 and X1, they are intersecting, so this, that is 0. Then theta 1 is, that is angle between x0 and x1. So here is your x0 and here is your x1. So when this when this rotates, okay, when this rotates, so this will move. Okay, so this x-axis will move along with the axis. So you will have an angle theta 1. So theta 1. Okay, and then for the second one, so these two related with z-axis. These two related with x-axis. Okay. So here again, this A is distance between Z1 and Z2. So your Z1 is here and then your Z2 is here. Okay. So the Z1, so here your Z1 and then from here only it starts. So it is intersecting. So there is no distance. Okay, then next one is your angle between Z1 and Z2. Your Z1 is here, Z2 is here. So you have an angle. So that angle is 90 degree. Okay. So now we have to check whether it is a anti-clockwise or clockwise. So if you want to reach this means your see this is my Z, this is my, so this one, two. So it should rotate like this. It should rotate anti-clockwise. Anti-clockwise is always positive because we are following right hand, we are following right hand coordinate system. So in order to align z, the angle between z0 and z1 is 90 degree, but it is in the anti-clockwise manner, so it is 90 degree. Okay, then distance between x1 and x2. So here your x1, here your x2. So you have a distance. So this distance will vary when this is varying. Okay, this joint is varying because of the prismatic joint. So this is the variable. Okay, then angle between x1 and x2. So the angle between x1 and x2 is 0. Okay, so we our DH table is done now. Okay, so now we are going to substitute in the DH matrix. So let's write the DH matrix, which we have done already. So this DH matrix is here. Let me write the equation. So it is C theta minus S theta 0 A. Then S theta C alpha C theta C alpha minus S alpha minus S alpha D. Then here S theta S alpha C theta S alpha C alpha C alpha D 0 0 0 1. Okay, so what is the matrix we have derived in the last thing? So that is A alpha D theta. Okay, so we have derived this is 0 0 0 This is theta 1. Next one is 0, 90 degree, D2 0. Okay. So let's substitute. So this is my 0 to 1 link, 1 to 2 link. So now we are going to derive the transformation matrix for T10. So in this C theta. So do you have theta? Yes, I have. So it is C theta 1. Okay. Next one is S theta. Yes, you have theta. So S theta 1. Then 0. Do you have A? In this, there's no A. So put 0. Then here S theta. Okay, S theta is there. But cos alpha. What is alpha? 0. Cos alpha is 1. S theta. So you have S theta 1. So here cos theta, C alpha, cos alpha is 1. So you have cos theta 1. And then minus S alpha, alpha is 0, sine 0 is 0. And then here sine 0 is 0, D is also 0. So this is 0. Okay. And then the next term, S theta is sine theta 1, but sine alpha, sine 90 is 0. Sine 90 is 0. Then here cos theta 1, sine 90 is 0. Then cos alpha, cos 0 is 1. And then cos alpha is 1, but D is 0. So 0. Okay. Yes. This is 1. Okay. So let's do T2 1. T2 1 means you have to take these things. So substitute over here. So do you have cos theta? Cos theta is 0. Cos 0 is 0. So 1. The next one is minus sine 0. So sine 0 is 0. Okay. So next one is 0. Do you have A? No, you don't have A, 0. So here sine theta is 0, sine 0. So sine 0 is 0. Then cos 0 is 1, but cos theta is 0. Okay, 1. But cos alpha is 90. So it is 0. Cos 90 is 0. Then here minus sine 90. Minus sine 90 is 1. So it is minus 1. Then here your D2 is there and also sine alpha is there. So alpha is 90. So sine 90 is minus. You have that value. So it is sine 90 is 1. So minus D2. Okay. Then let me check whether it is minus or plus. 1 second. Minus A into minus 1. Okay. So next comes this one. Sine theta, sine alpha. Sine theta is 0. So 0. Cos theta sin 90 is 1. So you have 1 because cos theta is 0, cos 0 is 1, sin 90 is 1. Okay, so cos alpha is 0. Then this term is 0, cos alpha is 0, 0, 0, 0, 1. Okay, so let's multiply. So when you multiply, it is T0. So multiply this. So this with this. So answer is C theta 1, 0. And this one, C theta 1, this. Then when you multiply this with this, so it is 0 only. When you multiply this with this, S theta 1. When you multiply this with this, S1 D2. S theta 1 D2. Okay, then when you multiply this, you will get S theta 1, C 0, and minus C theta 1, and so this should C theta 1 D2. Okay, minus C theta 1 D2. Okay. The next one is 0, 1, 0, 0, 0, 0, 1. That's all. So this is my OM matrix. Okay, so your matrix X, this is my X value. This is my X value. This is my Y value. Z value is 0 because this is planar manipulator. So planar manipulators mean you have X and Y only. So these are the orientation of that last frame with respect to the 0 frame. Okay, so this is how we are to do. So assign the axis, get the DH parameters, and find out the DH matrix using this formula and multiply, then you will get the OM matrix. So this is for RP manipulator. Okay, so let's take one more manipulator, that is problem number 2. So let's take 3R manipulator. So here is the base. So here is one link, And then, so here is one more link, and then here is one more link. Okay. So you have end effector over here. So what is the first step? First step is assign z-axis. So it rotates like this, it rotates like this, it rotates like this. Okay. So the axes are 1 and then z2, because this is revolute joint, so it is about the axis of rotation. So now we have to draw the x-axis. The x-axis is if two things are parallel. So let's initially start with x naught. Okay. So if two, because I have to draw x1. So x1 means I have to take z naught and z1. So they belong to a same point. So you can draw either like so here. Okay. And also your x1 is the common normal between z1 and z2. Okay. Then x2. X2 is, this is x2. X2 is common normal between Z2 and Z3 if they are parallel. Okay, then here common normal between this one. So it is X3. So we have drawn everything. So now we'll do the DH table. So DH table is A, alpha, D, theta. Okay. So 0 to 1, 1 to 2, 2 to 3. So let's find out that what is, so this you have to consider Z, this you have to consider X. So for this, Z0 and Z1, distance between Z0. So both are same, both are the same point, it is 0. So angle between, so that is also 0. So distance between x0 and x1, they are intersecting, so 0. And then angle between this one is, yes, you have angle is theta 1, okay, theta 1. Next, distance between Z1 and Z2, so Z1 is here, Z2 is here, okay. So this distance, let's say length L1, okay, L1. And then angle between, so both the angles are parallel, so it is 0. Okay, distance between x1 and x2 both are intersecting, so that is 0. Then angle between them is, so this x1 goes like this x2 is there, so you have theta 2. So it is theta 2. Okay, so next one is distance between z2 and z3. So this length is L2. So let's take L2. And angle between z2 and z3 both are parallel, so it is 0. Then distance between x2 and x3 both are intersecting, so it is 0. Then angle between, so yes, x2 is like this, x3 is like this. So angle is theta 2. Okay, that's all. Then you have to substitute in the equation. So if you substitute, you will get T10 equal to C theta 1 minus S theta 1 0 0. Substitute based on the formula. Then S theta 1 uh, C theta 1 0 0 0 0 1 0 0 0 0 1. Okay. So next T21. So T21 is, see, all are same only, but you have only this difference L1, L2. So it is C theta 2 minus S theta 2 0 L1, because A you have L1. Okay. Then here S theta 2 C theta 2 0 0. Here 0 0 1 0 and 0 0 0 1. Okay. Then T32 is equivalent to, so I'll put C3 or C theta 3 minus S theta 3 and 0 L2. And okay, let me look at the space. Okay, so T32, so equal to C theta 3 minus S theta 3 0 L2 and S theta 3 C theta 3 0 0, then 0 0 1 0 0 0 0 1. Okay, this all. So now we have to multiply these two. So let's multiply. When you multiply these two, it will be T20. So when you multiply it is C theta 1 C theta 2 minus S theta 1 S theta 2. Okay, then when we multiply this one is minus c theta 1 s theta 2 minus s theta 1 c theta 2. Okay, then this one is 0, then it is L1 c theta 1. Okay, so next parameter is s theta 1 c theta 2 plus c theta 1 s theta 2. Okay, so next one is minus s theta 1 s theta 2 plus c theta 1 c theta 2. Then 0, this one is L1 s theta 1. Then the remaining terms are easier only 0 0 1 0 and 0 0 0 1. Okay, so now we have to do the simplification. So what is simplification? So c theta 1 c theta 2 minus this one is, so this is equivalent to cos theta of theta 1 plus theta 2. Okay, this one. So here if you take the minus sine of theta 1 plus theta 2, then only sine theta 1. So these are the identity. Similarly, this one is sine of theta 1 plus theta 2. This one is cos of theta 1 plus theta 2. Okay, let's substitute that in that. So your T20 is equivalent to, I'm going to use C12. So what is C12? Cos of theta 1 plus theta 2, which is C1, C2 minus S1, S2. Okay, so C1, C2, so C12 minus S12, 0, L1, C1. Then here S12, C12, and 0, L1, S1. 0 0 1 0 0 0 0 1. Okay, then next parameter is, so I'm going to multiply with this. So you have to multiply T31. So T31 is C theta 3 minus S theta 3, 0 L2 S3 C3, 0 0 0 0 1 0 0 0 1. Okay, so now after simplification it becomes C123 minus S123 C1, sorry, L1 C1 plus L2 C12. The next one is S123 C123. C123 means cos of, so in this case, cos of theta 1 plus theta 2 plus theta 3. Okay, L1 S1 plus L2 S12. Then 0 0 1 0 0 0 0 1. That's all. This is your OM matrix. And then here is my x value, here is my y value. This is 0 because that is 0 because it is a planar manipulator. So this is the OM matrix of 3R manipulator. Okay, so what is the step? First we have to assign the axis and we have to derive the DH parameters, then you have to multiply it. Okay, so one more example. So this is my third example. So let's take the, let's draw one manipulator. So from this, you can identify what type of manipulator is this. Okay, here is my manipulator. Okay, so here, then let's assign the axis. First one is, it rotates like this. Okay, so here is my axis. So this is my 0 and 1 because for simplicity, I have assumed both reference and the first joint are same. So it rotates like this. Okay, it rotates like this. Okay, then second one is second here. So this, it rotates like this. So this is the joint. So this one is Z2. And then it rotates like this. So this is Z3. So this manipulator is called as RRR. Previous is also RRR. But see the design. In that all three are in the same direction. But here one is different. Okay. So let's mark x axis. Okay. So in that the first x axis is, so here it here is my x. So first, because your x is perpendicular to this, so let me take x comma 1. Okay, because x is okay, initially we give x, but x1 is we have to consider Z0 and Z1. So here is the plane. So perpendicular means I'm going to draw like this. So X0, X1. Okay. Then for X2, you have to draw the common normal between X2 and X3. So this is my X2. So next one is for X3, you have to draw the common normal between Z3 and this next one. So this is my X3. Okay, so we have derived everything, I mean the axis. So now the same thing like 0 to 1, 1 to 2, and 2 to 3. So what is that? So A, alpha, D, theta. Okay, so this one is Z axis, this one is x-axis. Okay, you have to come. So this is my distance. This is my angle. This is my distance. This is my angle. Okay. So let's see. So 0 and 1. So first you have to consider z-axis means distance between z0 and z1. So z0 and z1 are together. So it is 0. Angle between z0 and z1. So that is 0. Okay. Then distance between x0 and x1. So both are same. So this is the one. So angle between x0. So whenever this rotates, so slightly there is a movement. So this becomes x1. So you have an angle theta. Whenever this one rotates, you have different thing. Okay, your x1 varies, x0 remains the same. So the angle is theta 1. Okay. So next one is distance between Z1 and Z2. So here Z1 and Z2, they are intersecting. So it is 0. So angle between Z1 and Z2. Okay. So Z1 should move like this to align with this. So it moves like 90-degree. Okay. But it is clockwise. So clockwise means it is negative. Then distance between x1 and x2. X1 and x2 both are intersecting. It is 0. Okay. Angle between x1 and x2 is there. So you have an angle. So that is theta 2. Okay, next one is distance between Z2 and Z3. So you have a distance. So this distance, let's say L1. So this distance is L1 or okay, L1. Or suppose if you want to include this length, so this is L1, this is L2, but it depends. So let's say L2. Okay, angle between Z2 and Z3 is parallel, so it is 0. Distance between X2 and X3, they are intersecting, so it is 0. Okay, so you have an angle. So X2 comes like this. So you have an angle theta 3. That's all. So if any picture is given to you, you should be able to give the DH axis, I mean DH table, DH parameters. Then you have to substitute in the formula. Okay. So what is yes? What is A here for 0 to 1? A is distance between Z0 and Z1. Alpha is angle between Z0 and Z1. And D is distance between x0 and x1. And theta is angle between x0 and x1. Okay, so this is how we have to do. Then we'll do one more manipulator as well. So let it be fourth one. So let me check the simplest one. So let's take RPR or 1 second. Okay, so let's take this is also same. Okay, so let's take one more manipulator. So this, okay. So let's draw the axis. First, this rotates like this. Okay. So your Z0 and Z1. Okay. And then this one rotates like this. Okay. So your Z2. So it rotates like this. Then this is also, so here you have one thing, so that is also rotate like this. So here is the axis. So you can imagine this rotates like this, then this rotates like this. So z axis, then it is also rotating like this. So this is the axis Z3. Okay. So now we mark the x-axis. So x-axis means, so here, suppose if you consider, so this is my x0 and x1 because both are same. Okay. And then x2. So how to mark x2? So x2 means you have to consider Z1 and Z2. So Z1 and Z2 are intersecting. So I mean this is the plane. So this is the plane containing this. So let me take this as the x2. Okay. Then x3 is you have to consider Z2 and Z3. So Z2 and Z3 are parallel. Okay. So your x3 is a common normal between this. So I can draw like this. So this is my x3. Okay. That's all, we have given everything. So let me derive the table. So 0 to 1, 1 to 2, 2 to 3. So this is also 3-arm manipulator. So this is the axis of rotation. Here it rotates like this. It rotates like this. So this is the axis of rotation. Here is the axis of rotation. Okay. So let's derive A, alpha, D, theta. Okay. So the distance between Z0 and Z1. So Z0 and Z1 are same. Angle is also same. And distance between x0 and x1 is also same. And when it is rotating slightly, you have a variation in x1. So this angle is theta 1. Okay. So this is theta. When it rotates, you have a slight movement. So this is my x1. Okay. So next one is distance between z1 and z2. So here z1 and z2. So they are 90 degrees to each other. So you have to bring like this. So it is clockwise. So clockwise means minus 90, and distances it is intersecting. So there is no. So x1 and x2 is also 0. And then when it rotates like this, so your x3 will move like this. So you'll have an angle. So that angle is theta 2. Next one is distance between z2 and z3. So you have a distance. So this distance. So this distance. Okay, this distance is L. Let's take L. Okay. Then angle between Z2 and Z3 is same, so 0. Then distance between X2. Okay, so your X3 is here, X2 is here. So this distance, this distance, let's take D. Okay, so that is D. And then when it rotates, you have an angle. You have an angle like this, X3. So here is your X2. So between X2 and X3, you have an angle that is theta 3. Okay, so this is how we have to do the DH parameters. Okay, thanks for watching.